In part 2 of this series, I'll show you 4 more examples on how to identify redox reactions, their oxidizing agents, and their reducing agents. The question reads, determine whether each reaction is an oxidation-reduction reaction. If the reaction is an oxidation-reduction, identify the oxidizing agent and the reducing agent. Let's start with question A. We have 2 lithium atoms plus chlorine gas, and this yields 2 molecules of lithium chloride. The oxidation state of this lithium is 0 because it's elemental lithium, and the oxidation state of chlorine gas, Cl2, given that it's a diatomic molecule, is also 0. This yields chlorine, which is -1 oxidation state, and lithium, which has a +1 oxidation state. Now that we've determined the oxidation states, take a look at lithium. Lithium goes from being 0 to +1. This means that lithium lost electrons, therefore it got oxidized. Chlorine goes from 0 to -1. That's a reducing charge, therefore this got reduced. Now since we found out that this is an oxidation-reduction reaction, this means there has to be an oxidizing and reducing agent. The oxidizing agent here is the opposite of what got oxidized. So what got oxidized was this lithium, and therefore chlorine is the oxidizing agent. Chlorine gas. The reducing agent has to be lithium. That's the answer to question A. Let's move on to question B, and I'll erase what I just did here. In question B, we have 2 aluminum plus 3 ions of the element tin, and this yields 2 aluminum ions and 3 atoms of tin. Let's start with the 2 aluminums. This has an oxidation state of 0. This has an oxidation state of 2. This has 3+, and this has 0. Let's start with aluminum. We have to determine if this has been reduced or oxidized. And if you're confused about what oxidation and reduction is, remember this. Oil rig, this mnemonic. When you have oxidation, there's a loss of electrons. And when it's reduction, there is a gain of electrons. So aluminum, has it gained any electrons? In fact, it hasn't, because it's become more positive. It lost. Therefore, this is what gets oxidized. Tin, on the other hand, goes from being 2+ to 0. This gained electrons, therefore we have a reduction. This is a redox reaction, and the oxidizing agent for question B has to be Sn2+, whereas the reducing agent has to be aluminum. Remember, it's always the opposite. So this was oxidized, and it is the reducing agent. This was reduced, therefore it's the oxidizing agent. Let's move on to question C. Let's start with the oxidation states. Oxygen here has a state of 2-, nitrogen has a state of 5+, and lead has a state of 2+. Chlorine has a state of 1-, and lithium has a state of 1+. Chlorine here has a state of 1- as well, and lead has a state of 2+. Oxygen has a state of 2-, lithium has a state of 1+, and once again nitrogen has a state of 5+. As you can tell, none of the states have changed. Take for example nitrogen. It goes from being 5+ to still being 5+. Oxygen is still 2-, whether it's in the reactants or in the products. Therefore, this is not a redox reaction. Finally, in question D, we have solid carbon, and oxygen yields carbon dioxide. This one's easy. Carbon has a state of 0, this has a state of 0, and this has a state of -2, and carbon has +4. As you can see, carbon goes from 0 to +4. There's a loss of electrons here, so this is what gets oxidized. Oxygen goes from 0 to 2-. It's becoming more negative, so it has gained electrons. This is what's being reduced. Therefore, the oxidizing agent here has to be oxygen, and the reducing agent here has to be carbon. And there you have it. That is how to identify redox reactions, their oxidizing agents, and their reducing agents.